These are the most frequently asked homework questions from Algebra 2, Section 1-6, Day 2, starting with number 25. I'm not going to do any of the graphing of these. You certainly could do the number line for those. I don't see anybody having difficulty with that. So, number 25, we have 3 times the absolute value of y minus 9 is less than 27. And the first thing we would need to do is divide by 3 to isolate that absolute value. Then the next thing is to think, all right, this is a less than situation, so I need the numbers that are within 9 units of 0, which means this is going to be an AND statement. And our lower limit and our upper limit are going to be a negative 9 and a 9. Then we go ahead and add 9 to all 3 pieces. 0 is less than y, which is less than 18. And then, like I said, you're going to need to finish that up and do the number line graph for that. So you'll have open dots at 0 and 18, and you'll be shading everything in between. Number 29 is the next one that frequently is asked for. Again, we have to isolate our absolute value, so we're going to add 7 to both sides. Then we're going to divide both sides by 4. And now that we have it isolated, we're going to need to go ahead and again set this up as a compound inequality. Since this is less than or equal to, we are making an AND sandwich out of our 2w plus 3. It will go between negative 4 and 4. And then we'll subtract 3 all over the place. So negative 7 is less than or equal to 2w, which is less than or equal to 1. And then we'll divide all the pieces by 2, and that's a positive 2, so there's no need to flip any signs. And there it is. And again, you can go ahead and graph that on a number line. You'd probably want to go in 1/2 intervals with this one. And use closed dots at negative 7/2 and 1/2 and shade everything in between. Number 31, we've got solve each inequality and graph the solution. So 31 is the absolute value of x plus 3 is greater than 9. Now this one, we've already isolated the absolute value. It came that way. We don't see any additional numbers on the left-hand side that are outside the absolute value bars. So absolute value and greater than, this is an OR statement. X plus 3 will be less than negative 9, or x plus 3 will be greater than positive 9. And both of these we solve by subtracting 3 from both sides. And then we go ahead and make our number line. So this one's going from negative 12 to 6, which is going to be quite a ways, and I don't want to waste your time with this, so I'm just going to mark negative 12, 0, and 6 on here, because most of the time it's the solving part that people need the extra help with. So we'll need open dot at negative 12, since that doesn't have an equals bar, and we'll shade to the extreme, so going way down to the negatives on the number line. And then open dot at 6, and shade to the right forever. So that's number 31. Number 35 does have a number outside the absolute value bars. 35 is 3, absolute value of the quantity 2x minus 1, and that's greater than or equal to, whoops, let me get that on there so it doesn't look like an 11, there we go, and greater than or equal to 21. So with this one, we see that we have a 3 out there, and we've talked about how that's like guarding the absolute value piece. So let's go ahead and divide by 3 to get rid of that. This will cancel out. Now we didn't get rid of the absolute value. We still have to deal with that because, again, absolute value, always think of it as having 2 solutions. So this is absolute value with greater than or equal to, and that means we have an OR statement. 2x minus 1 is less than or equal to negative 7, or 2x minus 1 is greater than or equal to positive 7. So we'll go ahead and add 1
to both sides of each of these equations. And then we'll divide by 2. And because that's a positive 2, there'll be no flipping of the signs. And then we can go ahead and make a number line with these. So we'll have closed dots because these do have the little equals bars on here. Closed dots at -3 and at 4. And again, this was an OR, so we graph out to the extremes.
The next one on the list is number 59, so let me get that one up here. Number 59, and let's see, I'll try to fit this up here. All right, so first step with this one would be to divide both sides by -2. That doesn't look much like a 4 up there. I'm going to fix that before I go too much farther. There we are. And when you multiply or divide by a negative, you have to flip the sign. Now I want you to stop and think about what just happened. Now we're saying the absolute value of x plus 4, whatever that is, we know that's going to be a positive number. It has to be. We're talking about absolute value. Is going to be greater than -11. So what that means is we could put any numbers in for x, and this is absolutely going to work. So solve the inequality. This would be all real numbers. You could put infinity, and then when you graph it, you shade the whole doggone number line. That's what you do for number 59. Then number 61 is the absolute value of 3z plus 15. Pardon me, had to cough there. Is greater than or equal to 0. And again, you know, the thing to notice about 59 and 61 is when you go to set it up, things just look weird, you know, they don't feel right. And this one you would be saying, wait a minute, this is already a negative. Isn't that supposed to be positive, and then I have to do the negative? So then you know something strange is going on and you need to step back and look at the bigger picture. In this one, with the absolute value of 3z plus 15 greater than or equal to 0, when you go to set it up, you're going to say, well, I can't have a positive and a -0, so what do I do here? Well, then take another look. The absolute value, no matter what that is going to be greater than or equal to 0. It has to be. You know, it's either 0 or it's going to be positive. So this is another one where we would put all real numbers and then just shade the entire number line on 61. Move this up a little bit. And just enough to see number 63 there. So number 63 is 1/9 the absolute value of 5x minus 3 minus 3 is greater than or equal to 2. Again, you have to isolate the absolute value, so we're going to go ahead and add 3 to both sides. We have 1/9 absolute value of 5x minus 3 greater than or equal to 5. No flipping when we're going ahead and adding. Now to get rid of multiplying by 1/9, we're going to go ahead and multiply both sides by 9. And that's a positive 9, so we don't have to flip the sign. Now we have our absolute value piece, and we have greater than or equal to. So these distances are greater than or equal to 45, which means 5x minus 3 could be less than or equal to -45, or 5x minus 3 could be greater than or equal to positive 45. And then, of course, we just go ahead and solve those separately. So 5x is less than or equal to -42. Divide by 5. And x is less than or equal to -42/5. So that's the first part of this. And then we need our OR. And yeah, we're not too happy about that -42/5 there, but you know, you do with what you have. So then we go ahead and add 3 to both sides over here, and 5x is greater than or equal to 48. We divide by 5, and then x is greater than or equal to 48/5. But again, you know, really important there that you signify that or. So what you're going to need to do is put your closed dots at negative 42/5 and positive 48/5, and then you're going to shade outward to the extremes on that one to graph it. Number 65, let me see if I can fit that one up here so you can see it. And I'd best use a different color. All right, absolute value of x minus 3 over 2 plus 2 is less than 6. Just like before, we have to go ahead and subtract 2 from both sides. And we have it isolated, so now it's just a matter of saying, hey, you know what, that's a less than, so that means this is an and sandwich. So x minus 3 over 2 is going to be greater than negative 4, but less than positive 4. And now what we want to do is go ahead and get rid of that fraction, because that's probably bothering a lot of people as we go through this. So we're going to go ahead and multiply each of these pieces, I'll change colors here, by 2. All three of them. Here the 2's are going to drop right out. So we have negative 8 is less than x minus 3, which is less than positive 8. And then we go ahead and add 3 to all three pieces. And we would get negative 5 is less than x, which is less than 11. And you would put your open dots at negative 5 and 11, and then because this one has that and sandwich, our variable is sandwiched between those two, you're going to shade in between those two. Now let me scoot this up a bit in case anybody needed to see a little bit more of the bottom one there, which was number 63. And now I'm going to change gears and start talking about the little word problems. So number 69 talks about cooking. I'm going to try and write a little smaller and fit these in here. Suppose you used an oven thermometer while baking and discovered that the oven temperature varied between a positive 5 and a negative 5 degrees from the setting. If your oven is set to 350 degrees, let T be the actual temperature. So here's what happens. You open up the oven and there's a temperature T in there. And what you want to compare that with is a perfect 350 degrees. Now, it might be too high, it might be too low, so we need the absolute value bars in there because we're talking about how many degrees it is off. So we just want to know, what's the range? And right up here in the problem, they told us the range. Less than or equal to 5, because when you think about this, this is going to be a less than or equal to, that's an and sandwich, so it's going to be wedged between a negative 5 and a positive 5, which is exactly what they said was going to happen. Then in number 70, we have workers at a hardware store take their morning break no earlier than 10 a.m. and no later than noon. Let C represent the time the workers take their break. So we check what is the time that the workers took their break. Now, if what's acceptable for them is from 10 a.m. to noon, then right in the middle is perfectly when we would want everybody to take their lunch break. So that's going to be 11 o'clock. And of course, we're going to do the absolute value piece there because we're talking about a distance here. So then you think, okay, if somebody left at the very edge of the range, which is 10 o'clock or 12 o'clock, how far from 11 o'clock is that? And that's 1 hour. So the absolute value of C minus 11 is less than or equal to 1. Again, if you want to set this up, it would be between a negative 1 and a 1, which would indicate you can go an hour earlier or an hour after. Number 71, we're talking about climate here. A friend is planning a trip to Alaska. He purchased a coat that's recommended for outdoor temperatures from negative 15 to 45 degrees. Let T represent the temperature for which the coat is intended. Well, you might want to stop and do a little math here to figure out perfect. So we've got negative 15 on the low end, positive 45 on the high end, and we want to divide that by 2 because it's always the average that's right there in the middle. Or you could think of this as midpoint back from geometry. So negative 15 plus 45 is 30, and 30 divided by 2 is 15. So that's what we're considering the perfect temperature for this coat. Now what happens is you check the coat and see what temperature it's good for, and you have to compare that to that 15. And then you think, okay, well, If negative 15 was the low and 45 were the high, how far is that from that perfect 15 degrees? And the answer would be 30 degrees. And again, it can go under or it can go over, so we have to have that absolute value bar around there. Now, the last one that people will usually ask for is number 74. 74 says a length of 100 yards with a tolerance of 4 inches. We are to write an absolute value inequality and a compound inequality for each length x with a given tolerance. We already have a problem with number 74, and that is the labeling. One is in yards and the other one is in inches. So what we have to do is remember there are 36 inches in a yard, and take 100 times 36 and get 3,600 inches. So we're writing the absolute value for the tolerance. So what you would do is you would figure out, what do I have, measure whatever it is with this length that they're talking about, compare it to the perfect 3,600, and then you want to be within, they said, 4 inches. So less than or equal to 4. Now we're not done with this one this time because it said also write the compound inequality. So because this is less than or equal to, we're going to make an and sandwich out of x minus 3,600 with a negative 4 and a positive 4 because it could go in either direction. We don't know which. Then we'd go ahead and add 3,600 to both sides. And that would give us 3,596 less than or equal to x, which is less than or equal to 3,604. And that's the compound inequality. So we have our tolerance statement right there, and then we have our compound inequality down here. And that is it for the most frequently asked questions from section 1.6, day 2.